Good afternoon, everyone. We are delighted to have you join us today for this insightful webinar. It's my pleasure to join and welcome each of you. Dr. Dave Morroll, a Director of Clinical Support, will talk about quality control and KPIs.
Thank you, Adil. Good morning, good afternoon, everyone. Thank you for joining us. I've been asked to talk about quality control and KPIs. So over the next 40 minutes or so, I'm going to take you through some of the elements of quality management, quality control and use of KPIs that relate to the typical IVF lab. So as I mentioned, we can't really talk about quality control without putting it within the context of quality management. And when we talk about quality management, we're really talking about a system that ensures that the things that we do, the processes that we use, and the results that they give are fit for purpose and meet the requirements of service users. That's the core to what we're aiming to do. Now, if we look at quality management, we can break it down. This is from an ISO publication, Quality Management Principles. It can be broken down into 7 core elements, 7 core principles. A focus on the customer, the way we organize our systems, our management systems and leadership, how we engage people at various levels, processes, quality improvement, decision making and relationship management. And for the purposes of today, we're going to focus on these 3: the process approach, quality improvement, and the use of KPIs in that, and also evidence-based decision making, which is the crux of what we're aiming to do when we talk about quality control and use of KPIs. So let's look at process first. And the ISO document that I've mentioned essentially highlights the fact that when we're talking about a process approach, it really means that we're using well understood, well described and well managed processes to give consistency in our outcomes. So that if the more robust the system, the more consistent the outcomes we deliver to our patients. And that relies on making sure key processes are subject for improvement, that they give predictable outcomes. And again, KPIs help us see that. We want to optimize control of processes and use of resources, and that delivers confidence to all the users, whoever that is, whether it's patients, clinicians, and so on. And part of the actions that we can take, as well as thinking about the overarching elements of setting objectives, having clear responsibility for the bits that you do, we also want to provide good quality data, and we want to manage risks. And for the first part, we're going to talk about risk management, because that's a precursor really to using your quality control and KPIs. So hopefully you'll all have seen something similar to this. This is from the Health and Safety Executive in the UK, but that's what it's based on. But essentially it's a standard risk matrix that can be used to look at the severity of a problem and the likelihood of that problem occurring across this part. And essentially what you end up with a matrix where these in the top left are the least severe and least likely to happen, and over in the right bottom we've got the ones that are most severe and most likely to happen. And what we're looking to do during our risk assessments and management of risks is try and move our assessment of the risk to the left and to the top. So we're moving bottom right towards top left. So that's essentially what risk assessments do. They look at those risks, try and make them less severe if they happen, or less likely to happen, or ideally both. And these ones have to be addressed, the ones in red, and the ones in green you will manage. Sometimes you will just need to accept them because they are less likely to occur and less likely to be important. Now, of course, the sort of risks we encounter in IVF labs, we all know about the sort of things associated with equipment failure, poor equipment performance, and so on. So the obvious approach to risk assessment, risk management, is having a good system of surveillance and alarm systems for our critical equipment. And you will all know the sort of things we're talking about. We're talking about temperature, gas supply, levels of liquid nitrogen in dewars and so on, with a system of alerts that tell us that that's happening. So that's a very obvious example of how we manage risks. But we also need to think about how we ensure custody or chain of custody of gametes and embryos going through the lab. And this essentially relies on a robust chain of custody supported by some form of witnessing. And of course, witnessing can be done manually. That relies on colleagues, not necessarily lab-based, to help watch that we're doing what we say we're doing. It needs precise standard operating procedures and rigorous training. But we also know that manual witnessing, though better than no witnessing at all, comes with problems such as incomplete checks, checks not done at the same time as the process is actually being performed, and it's subject to causing distractions to the second witness being taken away from work. So you can adopt different techniques, such as the electronic witnessing systems highlighted here that use barcode or radio frequency identification tags to ensure that chain of custody through. So again, a second obvious example of managing risk, making sure that we track patient samples through the lab. But we should also add in traceability at all levels. So not just patient identity and their material going through the andrology, embryology and cryostorage areas, but we should also think about biopsied cells for PGT, consumables, equipment, and so on. Okay, the other principle that we've mentioned is the principle of improvement. So again, looking at the ISO document, the headline message here is that being successful in whatever you're doing is consistent with an ongoing focus on improvement. In other words, we constantly need to review and audit what we're doing to see where we can make improvements rather than staying still. If we stand still and don't look into it, that isn't going to lead to a successful laboratory. Now, that focus on improvement can improve performance. It can also improve capabilities. In other words, we improve by acquiring more skills, becoming more proficient. We also need to deal with those risks that we've just talked about, and they can be internal or external. And there should be a focus on root cause investigations. So in other words, what we want to do, as well as look for prospective improvements in the lab, what we also need to do is use root cause investigation as a way of looking at the causes of suboptimal performance. So what we can do is we want to educate and train to ensure people are competent, but we also want processes in place to drive improvement. And we need to track, review and audit improvement processes, and we'll touch on that in some more detail later on. But let's look at improvements and let's look at root cause analysis. So again, this is another example of a quality cycle where you plan some changes, you test those on a small scale, you analyze the data to see the impact of those changes, and then you act. You decide whether they are they've had a positive effect, in which case you implement them, or they've had a negative or neutral effect, in which case you move on to the next possible improvement. And that should be continuous. That should be something that you're doing over and over and over again, using your data that we'll talk about in a moment. So the quality cycle asks us to plan, do, check, and act. What we can also do is look at where we're identifying poorer performance. And although root cause analysis is often reserved for high risk, high impact events, we can actually use it as a way of looking at possible causes of poorer performance, and then promoting changes that will drive improvement. So we should have clear, robust procedures for recording and investigating poor performance, but also include near misses. So where we think that there could have been a problem, we can investigate that equally as well. And what we're looking to do is making sure that whenever there's suboptimal performance, we find out what's caused it, so that we can make sure that doesn't happen again. It's essentially learning from our own errors. Now, there's a number of different methods or little schemes that you can use to do root cause analysis. The classical one is this one, the so-called fishbone diagram, where you have some sort of negative event, the effect, and what you do is trail back through possible causes to identify the bits that have contributed. So I highlighted here on the fishbone diagram things like communication, often a cause of poor performance, training, so looking at competencies and where people are asked to do things that they're not fully comfortable doing, people, controls and management, the environment and equipment, and the processes we use. So those are the sort of things that feed into this investigation, and where we highlight weaknesses here, that might be the cause of the adverse event. So if we put some additional information on, so this is an example where we've had a mislabeled semen pot. So we can identify that we need better, consistent risk communication. We can see potentially lack of training in sample safety and chain of custody. Staffing, we might see that people are not adhering to the SOP. Audit of adherence to SOPs is a good practice to get into. We might find that people are passing on work to other staff, so that might be a weakness. We might not have effective double witnessing or verification of identities before receiving the sample, and so on. That just highlights the sort of way you track back from an adverse event and look at all the contributing causes to try and highlight weaknesses. And there may be one, or there may be several small factors that contribute to a larger event. Now, you can see this in a slightly different form. This is an example taken from the European Union Guide to the Quality and Safety of Tissues and Cells for Human Application, which is a document worth looking at. The 5th edition was from 2022, and essentially it's saying the same thing. It's doing the same thing, just slightly different graphical representation. So here they're looking at an increase in degeneration of oocytes after ICSI, and they're looking at materials, the procedure, the people, the management, environment and equipment. And you can see it's asking questions like, what culture media are you using? Have you changed the denudation pipettes? Is there a change to medication? Have you got new incubators, and so on? So you can see the principle there of trailing back, looking at elements that could contribute to an adverse event. Okay, let's move on to the next principle, which is the critical one in many ways to what we want to talk about, the quality control and the key performance indicators. That was the title of the talk. So here, what we're really talking about is using good quality data to drive evidence-based decisions. And from our ISO document, we can see it's telling us that analysis of data is more likely to deliver good results. That's the foundation we're working on, that in any system, not least an IVF laboratory, the better the quality of data, the more robustly it's collected, and the more accurate data that we can collect and then analyze effectively, the better our decision making will be. And if we make better decisions, we can improve our performance. We improve assessment of performance. And if we assess it well, then we can drive those improvements we've talked about. Now that has add-on effects, that it makes us more effective. However you determine effectiveness, that we often think about pregnancy rates, blastocyst formation, and so on. But you could also talk about, is it done effectively in the minimum amount of time needed to be safe and effective, or is it minimum cost to be safe and effective? And what we want to do, what our actions are, is to determine, measure, and monitor useful KPIs. So these key performance indicators that we'll come on to in a moment, we want to use those to drive our decision making. And the important message there is that the KPIs must be useful, and we'll talk about that in a moment. We want to make sure the data are accurate. We want to use suitable methods for analysis, and we want to make those data available to all interested parties so they can help drive the decision making as a group. So let's look at that in some more detail. So we're thinking, really, we've moved a little bit from quality management to quality control, and the difference here being that when we talk about quality control, we're talking about a system of inspecting, testing, and measurement of outcomes. We want to know what we're doing in the lab and what the outcomes are. And if we inspect, test, and measure those outcomes, then we can track back to the processes and see whether people are competent or where processes can be improved. So what we're testing with our quality control, all this data collection, is we're testing that the deliverables, in other words, what we produce in our lab, conform to specification, and we'll talk about benchmarking in a moment, are fit for purpose and meet stakeholder expectations, which is a rather grand way of saying that we deliver what we say we want to deliver. So if we want to deliver high pregnancy rates, we set ourselves a target, and then we test, evaluate, and then improve to make sure we consistently get those outcomes. And quality control activities determine whether we are meeting those criteria. So how do we do it? It's worth saying that where we're talking about quality indicators in healthcare, we want them to be standardized and we want them to be evidence-based. And we're quite fortunate in the IVF world now to have some help in that consideration. So we'll come on to that in the next slide, but we now have some support to provide standardized evidence-based measures of laboratory performance. And what we want is readily available data to measure and track clinical performance and outcomes. So hopefully what we have is some form of software, or it can be done manually at its simplest, but we have some way of collecting, collating, and analyzing important embryological and clinical outcomes that tell us that the performance of the laboratory is adequate, getting worse, or getting better. So these quality indicators should highlight potential improvement areas, and they should be tracked over time, which is fairly obvious, but worth stating. Now, the reason I said that we're fortunate in the IVF lab that we have standardized evidence-based measures is that we can reference these two documents, the Vienna Consensus, which gives ART laboratory indicators, and the Alpha Consensus, which is focused on cryopreservation. So these are based on surveys sent to national and international societies and clinical lab directors, reviewed by expert panels, and coming up with minimum expected values according to the indicators, and also providing benchmarks. And the benchmarks are our target value if we're performing well. So these documents rely on survey results, they rely on expert panels, where possible they also use standardized information from large data sets or national registers where that's available. So it's a good starting point for where we should expect to be. And this is what we end up with. This is taken from the Vienna Consensus, and we've got three types of quality indicator. We've got the reference indicators, which are really telling us about what's coming into the lab. So proxy indicators of ovarian stimulation. Performance indicators, which are the ones that are considered worth collecting, but maybe not so critical that we need to analyze them on a regular basis. And then the ones that we obviously are more interested in, the key performance indicators, which are related to the core business. And these are the ones that we would want to take a closer look at more routinely. Now, it's worth mentioning that I'm going to focus on the key performance indicators. I would also steer you towards this paper from Fabozzi and colleagues from a couple of years ago now, where as well as the outcome KPIs that we're more familiar with, the fertilization rates, cleavage rates, blastocyst rates, as well as those, they highlight the importance of other types of KPIs. So the ones that they described as structural KPIs. So have you got enough room in your cryo storage tanks? Do you have enough equipment? Do you have enough incubator space? And then also process KPIs, where you're looking at things like how often do staff members report injuries, or perhaps reporting ill, or how many times you get returned embryos at transfer, things like that that don't necessarily appear in your outcome KPIs. So worth reminding ourselves that whilst we're going to focus on outcome KPIs, these other structural and process KPIs are potentially equally important, and particularly as a lab director seeing the overall workings of the laboratory system. Okay, so this is taken from the Vienna Consensus. This is the performance indicators, the slightly less important in their view. So you can see I'm not going to go through all of these individually, but you'll see it relates to how motile your post-preparation sperm sample is. And you can see there's a competence value that's shown by the tick and a benchmark value shown by the star. This is what you should be getting, and this is what you should be aspiring to. So you could see it for sperm prep motility, polyspermy after IVF, and you can see the figures are the same there. The single pronucleate oocytes at fertilization check for IVF and Dixie, and good blastocyst rate on day 5. Some key messages there. First of all, when we look at 1PN rates, for example, we know these are quite different from the 1PNs in ICSI. So some evidence suggests that in the 1PN zygotes after IVF, there's possibility that almost half of those are actually diploid, but the second pronucleus hasn't been seen for some reason. That's very different from the 1PNs in ICSI, where the diploidy rate is probably much lower. It's probably in the region of 7 to 14%, and those ones that go on and develop into embryos usually have significant genetic abnormalities. Similarly, it's worth mentioning with the good blastocyst rate that if you only use day 5 rather than day 5, day 6 and day 7 together, that might be more of a useful indicator, and we'll talk about that in a few slides. Right, busy slides, the next two, but these are showing the KPIs for the laboratory, and you can see the competence figures with the tick and the benchmark figures for the target value, the benchmark value. You can see that we've got them for fertilization, degeneration after ICSI, cleavage, stages of development on day 2, day 3 and day 5, successful biopsy and so on, and the usual implantation rates, of course. So again, I'm not going to go through every one in detail, but you can see they cover the sort of things that most IVF labs would be interested in, and would want to have some idea of how their lab's performing. Similarly, when you look at the KPIs from the Alpha Consensus document, the Istanbul Consensus document for cryopreservation, they provide the same sort of information for different stages. I've only put oocytes and blastocysts here. They also provide it for zygotes and for cleavage stage embryos. But again, they provide competent values and benchmark values. And typically for survival, fertilization, development, implantation, and you can see that the expected outcomes, which will be no surprise to any of you, are slightly different for freezing, which is this sort of turquoisey color, aqua color, compared to vitrification, which is in the dark blue. So generally the KPIs are suggesting that if you've moved successfully to vitrification, you should be getting or expecting better results than you would with the slow freezing techniques. But essentially, these two documents are giving us a great overview of what we should be expected to be getting from the average laboratory if we're competent, and it's giving us target values if we consider that we're operating at the high end of outcomes. The caveat being, of course, that we have to take into account that different labs might have different patient groups, different patient populations. So it's worth perhaps trimming your KPIs to a good prognosis group, so you're evaluating lab performance rather than just variations in patient population. Another thing to mention is that as good as those two documents are, they don't cover everything. And I've just listed here some extra key performance indicators that you might consider. So for example, utilization rate, one I'm fanatically keen on promoting, is the rate of utilization, because it takes out debates about what's good quality, bad quality. If you use it and you use it in a consistent consistent manner, then that's more robust as an endpoint. But also how many oocytes you need to produce one clinically usable embryo, the healthy baby at home rate, cumulative pregnancy rates, survival rates post-biopsy, survival rates post-warming of biopsied embryos, and a misdiagnosis rate, for example. None of those appear in the documents. They might be clinically useful for you. And that comes back to what I said earlier about defining your KPIs and only analysing the data that is useful. Don't waste your time analysing lots of data that ultimately isn't going to help. So think about which KPIs you really want to be evaluating and make sure you concentrate on those. You can collect the data on the others, but you don't want to use up too much time analysing data that ultimately doesn't impact your decision making. Again, it's the evidence-based decision making that this data collection and analysis is really linked to. As I've said, if you want to monitor lab performance, you'd want to take out the element of patient variation. So you'd probably monitor KPIs against gold standard patients, those patients that have a good prognosis, good chance of becoming pregnant. And bear in mind that when you analyze KPIs, depending on the KPI, you may not get meaningful data for some time afterwards. So for things like embryology data, the utilization, cleavage rates, and so on, you'll probably get meaningful data relatively quickly, but it's still after a few weeks. When you're looking at implantation and pregnancy data, that's probably going to be 4 to 6 weeks after the event. So you've always got a lag period between the event and the analysis of the data relating to that event. So you need to keep that in mind. Now, I've also mentioned benchmarking. We want to know how well our lab performs relative to other labs, and that's where the benchmarking comes in. We can provide internal benchmarking, so previous outcomes or goal setting. So you can either do it on historical data and show that you're showing stepwise improvements, or you can set an internal goal and aspire to that and work towards getting to that level. Or you can use external benchmarking where you compare your outcomes against outcomes reported in the field, whether that's in published literature or, for example, in the consensus documents that we've already spoken about. Now, when you've got your data, you want to be able to analyze it in some way, and the fairly consistent way that we suggest doing that is to do it in a control chart. So this is looking at historical data and plotting the mean of monthly results, plus or minus 2 and 3 standard deviations. You can do that in an Excel spreadsheet very easily. And what you then do is you put your new data over the top, and you get information like this. So this is your historical average, plus or minus standard deviations, and then you plot over the top. And what you're expecting is, if you are performing consistently, these new data will bumble along around the average, the mean value in the middle. And if it goes above these 2 standard deviation warning limits, you start to take a look. If it goes above or below the 3 standard deviation limits, you certainly start investigating. And what you're looking for is outliers like this. So that may or may not be a problem, but you would have a look. That one you would certainly take a look because it shouldn't be that far different. And you can also look for trends. So things like this, where you're getting consistent reductions, you would look for an evolving problem and investigate. Or the opposite, if you're suddenly performing really well, then these historical data sets become less relevant and you would redefine them. So you'd recalculate the targets. Now, a good example of that sort of system being used is in this really nice paper by Hammond and Moorbeck 4 years ago, where they showed early detection of events using this particular KPI. So we're back to my favorite KPI, the utilization rate, but it's a particular one. So this is the day 5 usable blastocyst rate. which they call the D5 BUR. And they present data in this paper where they changed culture medium, and the day 5 utilization rate dropped down from 32% to 25%. You can see it here. And the important thing here is that it was detected within a week. So it's a quick outcome, a quick visualization of performance of the lab. They changed the median back, and you can see that the results gently climbed back. What they also report in this paper, interestingly, is the clinical pregnancy rate also dipped during this time, but it took 3 months to detect that compared to the 1 week with the day 5 usable blastocyst rate. So a good example of targeting your KPIs to give you quick wins and good oversight of lab performance. Now, another interesting one, this is from Borman and colleagues from a couple of years ago. Here, what they were doing is they were comparing manual measurement of KPIs with ones that used outcomes of embryo assessments based on an AI system. And what they showed is that the AI systems also help give systemic early detection of adverse outcomes and can show clinically relevant shifts in things like pregnancy rate and utilization rate. So it may be that this isn't in common use now, but it may be that we'll be able to refine our use of KPIs using AI. We can also use KPIs to support our training. This is the use of what's known as cumulative summation and learning curve cumulative summation charts that are used in this case for training of in vitrification. And essentially it's a method of mathematical modeling, not easy to say, mathematical modeling that allows you to look for acquirement of proficiency. So it determines when someone's become competent, when they reach this critical point here. And then what you can do is by maintaining that information, you can see whether they lose their competence. Now in this, they would have to go above this dotted line in the cumulative summation part of the graph, which neither person does in this particular case. There is another paper that looks at embryo transfers, for example, that shows that clinicians who don't do transfers for a period of 2 weeks lose their competence. We don't talk about that too often. We've already mentioned witnessing and electronic witnessing. Another important factor here is that we can use the same systems. When we witness, we can use that information, use the timestamps from the witnessing system to collect data to tell us about average duration of events, where they've happened, intervals between events, and we can select it by where it's happening and who's doing the procedure. So it gives you a whole range of extra data that helps drive refinements and improvements. And for instance, our Witness IQ system is designed around that principle. And it's also been used to give some really helpful feedback on automated timestamping as a tool for studying how processes are performed. In this case, it's both relating to ICSI and how timings of events affect clinical outcomes. So again, making sure we collect robust data that drives decision making and improves performance. Now we can collect all the data we want and we can do our routine KPIs, but actually an important element of it is also to build in some degree of self-audit. And audit can be a slightly unnerving word to use, but essentially what you're doing is looking to review performance, check adherence to SOPs, help in troubleshooting. We tend to focus on troubleshooting and poor performance, but we can do this routinely to drive improvements. We can look at one process or a number of processes, and essentially audits are just a way of reviewing the data as part of our quality improvements and quality cycle. Now, it's very easy to do internal audits rather than relying on external. We can check status at a specific time. We need to be objective, but make clear these are not an exam. It's not a pass-fail. It's about informing decisions again, that evidence-based decision-making. And we're not looking to blame people. More often than not, audits, in my experience, either pick up a problem in the process and the procedures used, or a gap in training. It's very rarely related to poor performance by an individual. And they'll take two forms: a horizontal audit, which means you audit one process across a number of patients or a number of cycles. So, for example, we might look at how semen samples are received into the lab on a day. Or we can do a vertical audit. So that's following one patient or one cycle through all the processes and reviewing that way. So you can take both approaches and you can target them to look at particular processes and weight them to look for areas of particular interest. Okay, that was a whistle-stop tour of use of quality management, quality control and KPIs. Just to summarize, we started by highlighting the fact that awareness of risks is fundamental. We also said that quality improvement is an essential tenet of quality management. It's got to be central to what you do, and it should be continuous. Improvement that we're looking for needs careful, considered and well-structured investigation of adverse events, poor performance and near misses. And given that we want to use data to drive good decision making, evidence-based decisions rely on the collection and management of good quality data. So we have to put that as our starting point. Internal quality control should use quality indicators or KPIs to monitor performance. And we've talked about the outcome KPIs, but also highlighted structural and performance KPIs. We've also highlighted the consensus documents, published studies and in-house data can all be used. And the consensus documents, the two we've highlighted, are a good starting point. And I would urge you to focus on clinically useful KPIs. We all work in busy labs with limited time, so you should consider where you put the focus, and clinically useful ones, such as the day 5 usable blastocyst rate that Hammond and Moorbeck highlighted, is a good starting point. Remember that data is also important for showing competence and effectiveness of training. And we should also use those targeted audits to support our quality management system, performance improvement, and troubleshooting. Those are a few of the slides that I've referenced, and those are my contact details if anyone has any reason to contact me afterwards.